because we have a pretty packed schedule, right, Akif? So we have a lot to cover today.
Yeah, definitely.
So let me go ahead and start sharing my screen here. Okay, you can see my screen, Akif?
Yes, I see you.
Perfect, perfect. Excellent. Well, a very sincere welcome to everyone who have patched in here to this masterclass today. It's, as always, super exciting to see so many people showing interest on LinkedIn, so many people signing up for these types of masterclasses. It really makes us motivated to continue making them and to provide this sort of knowledge for the professionals out there. And today's masterclass then that you have logged into is about AI in ServiceNow ITOM. So this topic has always been a little bit, let's say, mysterious, because a lot of people, when you hear the concept of AI, then there tends to be a lot of assumptions of what AI is and what it should do, and there is essentially a lot of confusion. So me, together with my colleague Akif here today, we sat down and we had a discussion about, can we try to demystify this concept of AI, especially in the context of ServiceNow ITOM then? And that's what we're going to do here together today. But before we get into the actual webinar, then I think a little introduction makes sense. So me who speaks right now, my name is Alexander Ljungström, and I am the Managing Director at Einar Partners. For those of you who have previously attended masterclasses by Einar Partners or who have followed us on LinkedIn, you probably have seen my name once or twice or thrice, maybe. But I am very, very passionate about IT operations. And I'm also very passionate about the topic of AiOps, or artificial intelligence operations. So previously, I used to work at ServiceNow in the beginning of my career in their ITOM team. And since then, I've had a long, long journey when it comes to IT operations. But these days, really what I'm doing is that I'm advising clients and companies around the world on the strategy when it comes to ServiceNow ITOM. However, I am not alone here today, but I have a good colleague with me, Akif. So who are you, Akif? And what is your background to this field of AI? Because you have quite a good background, so.
Yeah, so thanks, Alex. Yeah, I'm Akif. I'm the R&D lead AI Ops and data science at Einar Partners. And yeah, I have a background in econometrics, data science, AI, and yeah, quantum computing. What I love to do, it's, you know, all making sense of data, like modeling and creating statistical models, and yeah, like demystifying actually also, you know, AI applied anywhere actually, and that's what I love to do, and I'm really excited to organize this masterclass together with you.
Yeah, excellent. Super cool to have you on board, Akif. We're gonna have a lot of fun here. So now for the audience here, we pretty much have 55 minutes, and this is a huge topic when it comes to AI, and it's absolutely an enormous topic if you look outside of ServiceNow. So we will have to try and time box it a little bit, but kind of just to set the expectations. So what you can expect to learn today. First of all, when me and Akif, we sat down and we planned this masterclass, we thought it makes sense to just kind of define the very core concepts of machine learning. Naturally, this has been done before, but I think for a lot of people on the call here today, it's kind of difficult to grasp what really is machine learning, what is AI. So we want to set those concepts straight from the start here. Then we will speak a little bit about how we can apply the topic of AI, the topic of machine learning, and especially then in the relation to metrics and models and classifications. I know what some of you might be thinking now, that, whoa, Alex, this sounds very, very technical. It's a little bit technical, I'm not gonna lie, because AI and machine learning is a technical field, but we will nonetheless do the best to kind of give let's say, a high-level overview on these topics. So for those of you who think that you will be sitting and learning algorithms today, that's not the case. We might have follow-up webinars about that, but today we're scratching the surface here. But an important part when we speak about machine learning, when we speak about AI, is predictions. And you, Akif, you have done some good work here of kind of debunking what predictions really are. So I'm looking forward to hearing your take on predictions, because as we all know, predictions is a big thing in IT operations, in monitoring and so forth.
Especially talking about the future. So.
Especially talking about the future, exactly. But more importantly, we want to try and bridge all of these theoretical concepts to how that can relate to the journey of ServiceNow and kind of the relationships between all of these different concepts then. So I hope that makes sense. And just some practical information before we continue. So we will have a Q&A session in the end, which means that you should see one of these Q&A chat functions in the Zoom webinar, which means that you can then write to me or Akif, and hopefully we can get around to answering the question. If we don't have time, we'll reach out to you personally with a reply. Additionally, this is being recorded, which means that if you have colleagues, if you have friends, etc., who would be interested in this, but they are not here today, you can send them the recording afterwards. And of course, we will send you the link, etc., to that as well. So with that being said, what do you say, Akif? Should we get this started?
Yeah, let's start.
Yeah, and I think you are the first one here, because we had a lot of interesting discussions about this phenomena of intelligence. So why don't you take it away here and let's dive in deep.
Definitely. And let's dive into the intelligence part of the AiOps. And intelligence, it's a phenomena. I mean, you can't see it, but there's not the really like tangible product of it. It's like a force, you know. You observe force when you act upon it. And there's some intelligence process of the phenomena, and it starts all with the data. And as here in the pyramid in the bottom, let's go through the steps of the intelligence process as a process. And so when we have data and we structure and pre-process and data, we get information. And once we have information, we can start modeling it and analyzing it. And once we analyze it, we get knowledge. We start to understand it. What is the data all about? Intelligence itself is all about making sense of data. And once we start interpreting the knowledge, information, and data, we kind of get the phenomena called intelligence. And once we have a good understanding, knowledge, and understand and make sense of our data, we can start, make decisions upon it and act upon it. And that's actually the top part of this pyramid. And all this process, if you put it in the context of AiOps, IT operations, we can create this artificially on machines. So, intelligence is a phenomena, and we talked about AI, and how can we do that? How is that actually created on machines? So you may heard of artificial intelligence and machine learning, and I want to take a deep dive into a bit the AI concept and machine learning, because especially later on, we will talk a lot about it, especially how it's applied within ServiceNow. So what do we mean when we speak about AI and ML? So AI is kind of like intelligence demonstrated by a machine. It's like an all encapsulating a concept. It's a program that can mimic human behavior and sense, adapt to its environment. But as you have, observed before in the pyramid, there's a, you can't have AI and intelligence without learning from the data. So we have machine learning that learns and improves from experience. And machine learning is part of AI. It's a kind of subset of it, can we say? So how does machine learn? There are several ways and approaches. We call it can learn, by supervising the algorithm. So kind of guided learning algorithm that, match the marked input to desired output. There's kind of like a teacher, helping to learn the algorithm. We can do it in an unsupervised way. We look at the data, we try to discover like patterns within the data. We can do that maybe in a reinforced way, actually much more in a dynamic way. Like there's an agent learning with reward and punishment. So when it learns well, it gets a reward, and when it didn't learn well, it gets a punishment. And there's also a concept called learning called deep learning, which tries to imitate actually human learning. It tries to mimic human behavior, and the scientists even try to mimic how child or kids learn, and then try to put that in an algorithm.
So Akif, a question here, because you and me had quite a few discussions about this.
Yeah,
and
a lot.
If we look at so first of all, how I interpret this image is that when we speak about AI, that's really the wrapper, so to speak, around all of these different concepts, like machine learning, supervised, unsupervised, deep learning, etc. So AI is more the generic name of all of these different methodologies. Would that be fair to say that it's kind of a wrapper around it?
Exactly. It's exactly like so. It's kind of like that wrapper, and it's a little bit more like on the top of that pyramid. AI can it's also about decision making and act upon it from what you have learned.
Exactly. And I think you hit the nail on the head there, because that is often what I see the holy grail is when we speak about IT operations, when we speak about AiOps. I've heard this expression once, which is AI is easy, operations is hard. So basically interpreting the data, getting these algorithms to work, which we're going to speak about more later, that's the easy part. But then acting on that data, that's the more difficult part. So that pyramid, I think the longer, like the higher up you want to get in that pyramid, the more cutting edge and difficult it is, perhaps, or more challenging.
Of course. And we will get later on in also about why it's difficult.
Yeah, exactly. And then just one more thing here, because you are clearly more in-depth expert than I am in this topic, but we had a discussion about supervised versus unsupervised machine learning. And if I understood you correctly, by the way, we have both of these concepts in ServiceNow, supervised and unsupervised. But the supervised, we basically tell the algorithms to look for certain patterns, to look for certain things. Meanwhile, unsupervised, if I understand you correctly, then
yes.
It does that by itself, correct?
Exactly. I couldn't describe it better. And that's what exactly the supervised and unsupervised machine learning algorithms within ServiceNow does. So when it gets its data from the applications, it looks either to certain patterns that you already said, look for that, or it looks at data in an unsupervised way, what kind of patterns are there? So right. Yeah, like you said.
Okay, but that makes sense. That makes sense. But let's take this then into a context of ServiceNow ITOM then, because I think this is a good bridge then. So how can we look on this on ServiceNow ITOM? So I'm going to steal here the screen sharing back from you. And then so just like Keith explained, we have all of these different machine learning concepts in ServiceNow ITOM, but I think now what I would like to try and do, because now we established two pretty fundamental core concepts. One is the pyramid of intelligence, that we need to try and define what intelligence really is. And as we can see, just interpreting data, that's simply just half of the picture, but you also need to act on the data. And then furthermore, when we speak about artificial intelligence, it's primarily within AI that we have various ways of machine learning, statistical models, etc. So in front of you here is a maturity model of ServiceNow ITOM, especially when it comes to the visibility and health parts. I'm not going to go through the entire maturity model today, but to make it simple, from the left side, we have the first steps, which is always like ITSM, incident, problem, change, the normal stuff. Then organizations and customers, they tend to start with the consolidation of data. So they start building this data lake, like with Discovery, with a CMDB. And then slowly, customers and clients and organizations, they continue this journey in ServiceNow ITOM when it comes to service mapping, event management, consolidating events, etc. But then on the very far right side, that's where we have the AI-driven parts. And this is where it gets a little bit confusing for people. So the truth is that machine learning, it exists in almost every ITOM module in ServiceNow. So like when I started working with ServiceNow ITOM, which is almost 10 years ago soon, oh my God, then machine learning wasn't really a thing yet. But if we look today at the usual suspects, so these are the modules that a lot of organizations are using when it comes to ITOM. In things like Discovery, we have application fingerprinting. In service mapping, we can analyze traffic and we can get connection suggestions. So based on TCP connections, we can get a lot of suggestions for how we're going to build our service maps. And then when it comes to the event management part, we have things such as natural language processing. So we recognize text and patterns in text on incoming alerts. And we can also cluster these alerts. So we can group them in different ways, in different logical orders. And all of this is done to a large extent through one method or another with machine learning. But here's the kicker, that this is merely features. Just because you are using these features doesn't really mean that you as an organization are working with like an operating model that uses machine learning. So that's really where the AiOps and metric intelligence part come into the picture. So on the maturity model, that was the one to the very far right. And this, for me, creates a fundamental difference because this is truly a new way of working for a lot of organizations. And only 5 years ago, this was very, very difficult to work with, like AiOps, machine learning, metric intelligence, etc. But these days, we see things like in ServiceNow, we have off-the-shelf, commercially ready products, which is easy to get started with. But nonetheless, it has like a very, very big impact on the operating model and how monitoring teams are working. And that's really what we're going to speak about now for the coming 40 minutes. So we will not really touch upon the machine learning parts of like discovery, service mapping, etc. But we will really look at how can an organization take that next step and really proudly claim that they are working with machine learning and AI. So that's what we're going to get looking at here.
Yeah.
Now, the very first thing this starts with, if we speak about machine learning in ServiceNow, and if we speak about AiOps, is something called time series and statistical modeling. So you and me, Akif, we'll have to try and do a good job here at keeping this like to a fairly high level. But I want to start off with the time series data. So most of you probably have heard about it before. Some of you maybe haven't. But the time series data is like the fundamental core concept of any machine learning in ServiceNow when we speak about AiOps. So I'm just gonna explain quickly what is time series data and how does the format look and what are some practical examples. And then after that, you, Akif, you will explain a little bit more around the classification and statistical models.
Yes.
All right. So what is then what is time series data? In a nutshell, time series data is a sequence of data points that occur in a successive order in a particular time interval. Maybe that doesn't tell anything to you. So I'm going to put that into a more tangible, graspable concept. So here is a box of some examples where we have like CPU, we have memory, we might have number of transactions, what bandwidth is in use, disk, whatever it might be, response times on websites, etc., etc. The common thing with all of these metrics that I'm mentioning here is that they are happening every minute or very, very frequently. And what I said there, metrics, is perhaps the most important part. So really what we are doing is we are looking at metrics and we are saving those metrics every minute in what is known as a time series database. So ServiceNow, when you get started with AiOps, then you will actually get assigned your own time series database, which is a separate database outside of the ServiceNow instance. It's called Clotho, the database. But the purpose of this database is essentially to store time series data. And when you look at, for example, application monitoring tools, SCOM, Dynatrace, etc., they are reading metrics. But the difference here is that these metrics are being saved in a time series format in a time series database. So when we can save these time series, when we can save all of these metrics in a database, that's when the really interesting things can start happening, because then we can see over time how are certain metrics for certain applications performing. And based on that, we can also see behaviors, we can see trends, we can see a lot of things. So I think I'm going to leave it at that, but I just wanted to mention here that the time series data is pretty much like the core concept when we speak about AI and ML in ServiceNow AiOps. Would you like to add anything here, Akif, or does it make sense?
It makes all very good sense, and especially like the time dimension, it's important. That makes it the time series data, and time right. It's a very important dimension of it. So
yeah, exactly. And actually, it's good that you say that, because when we look at traditional metrics and monitoring, like if you're lucky, they save it for maybe a day. You can see metrics if you visit SCOM, or if you go to your own CPU on your computer and you open the task manager, you maybe can see how has the past minute been. But after that minute, data isn't really saved anywhere. But that's the difference here. We are actually storing that data, sometimes for days, sometimes for weeks, and sometimes for months.
Yes.
So thanks for adding that. But then, Akif, how do we classify this?
Yeah, we have really nice machine learning algorithms for that. And in case of like ServiceNow ITOM, we have fancy supervised machine learning algorithms like the KNN naive Bayes decision tree. And maybe in a later masterclass, we should go more in the technical details of it. But to give you an impression, of how machine learning is when it's in action. So when the metrics data is collected, like you said, from the applications, it's fed into these supervised machine learning algorithms. And then this is done in the training phase. So there's like a training phase, a test phase, and then it can be, if it has good predictive power, the models can be used. In the training phase, it trains on the incoming data. And then it builds a model, and then the best model that gives good prediction against on the test data, it's chosen and then used further. And let's dive a bit more into this process. So to make sense, so why do we need to know more about the data, or why should we actually fed it into supervised machine learning algorithms? And the reason is actually, so when the operational metrics data is collected, it has certain behavior patterns, and we want to know about that. And the reason is why we want to know about that very intimately or very good. It's we want to create accurate statistical models based on that. Like when we get operational metrics data, for example, from your Azure, that's collected in case of ITOM with an agent client collector. It's kind of a scraper. It collects all these data in a time series format. So it's like a pre-processed kind of and structured. And then it's fed into these supervised machine learning algorithms. And then the supervised machine algorithms learns about the data. And then it says it contains like a seasonal pattern. It contains, trends. And once we know about that, then we can create like statistical models, based on that, because, and the reason why, I'll show you that in the next, in the next slide. For example, in the top plot, we see a request rate, right? We see a pattern that's recurring, like, through the day, it's high, in the evenings, it goes down, but we see a recurring pattern. And on the bottom, we see like the trendy data or trendy pattern. And we see that it starts from Monday up till Friday. It goes higher and higher, the used memory. So, and then on Friday evening, it goes down, and then the last memory is used. And then on Monday, it starts again. So a recurring trend. And why should we know about this? So if we don't know about these patterns, then, and we create random thresholds for our statistical models, then we get inaccurate predictions. But then, why do we create statistical models, and why are they important? Well, a statistical model, like you model kind of the data generating process. You try to kind of model actually how the data, all these time series data, operational data metrics is modeled. And why do we want to do that? Because we can then make predictions. We can, make statements about the future. So, and that's, that's a part I love from like data science and AI, ML, and econometrics. So, talking about the future. So once we capture how the data is created, once we model and create a statistical model, then we can start making predictions. And then here, I mean predictions, future values. Like we can start making statements about what the expected value in the future might be, how the data or the behavior would look like. And why do we want to do that? So we can, deal with uncertainty, and that's and if you like from the at the beginning, we talked about why it's difficult sometimes to make decisions on data because there's some uncertainty involved, and so we want to deal with uncertainty. And we also, once we can deal with uncertainty, once we can, make predictions, make statements about our data and future data, we can also, say something about, normal, good behaving data and abnormal, not normal behaving data. And why is that important? Because you want your business applications to run in a certain way. You want it, your applications to run smoothly, without any headache, and also in the future. And if something happens, you want to anticipate already before it happens. And that's what ServiceNow also does a lot. They have predictive intelligence and anomaly detection systems. And the reason why is because we want to anticipate issues and problems before they happen. So
yeah, and I think we do that with total sense, Keith. Sorry to interrupt, but no. I think you hit the nail on the head there again, because uncertainty, the world of IT operations is growing more and more complex every year. So the way we work with applications, the way we work with business systems, whatever it might be, the complexity is growing. And we see this a lot lately, the past years, with things like DevOps, more and more monitoring tools, you have cloud, like all of a sudden you have all of these dependencies. So when you have so many dependencies, then all of a sudden, how I at least see it, is that it becomes really, really important to track what are the behaviors over time. And like you mentioned, seasonality. If we put that into a context, if you are a company which has like a web shop perhaps, and then it's Christmas, well, we're almost in Christmas now, so a lot of people are buying things online, then obviously you can expect a higher degree of traffic, a higher degree of orders, and then you have a seasonal trend. So I think to become, a next step in truly a data-driven company, then tracking the behaviors of applications is key. So it's not only enough to react that, hey, we have a problem, but you want, like you explained, intimately know how is the behavior of our applications, how is the behavior of our infrastructure, correct?
Yeah, exactly. You want to know that, like you should know that your CPU power, for example, or your servers are not working too much because there's like an anomalous intrusion, or there's an your computers are hacked, and that's why it's using, instead of like while that in Christmas time it increases because it's Christmas. So putting it in the right context, that's why it's important. If it was like in the summer, you would know then there's something else going on, like then you can look at it. Yeah.
Right. And then you mentioned here, before I cut you off, triggering anomaly alerts. Could you expand upon that? Because that's what it's all about, right?
Yes. So at the end of the day, so when we make predictions, we want business applications to run in a certain way, and when it comes to anomalies, like anomaly detection systems, so I talked about that we train the models on training data and test data, but we also want to anticipate like future values out of sample, like in this case, when we talk about anomaly detection systems, we are talking about the future anomalies that might occur. And then whether it's like, it depends on the organization of the business. So when the alerts are triggered, either it's automatically, like actions are automatically taken to solve the probable issue, or the alert goes to a human operator who takes, action, or who looks at it and, and then takes a decision based on these alerts. But, so there's some kind of coming back to the uncertainty, and I want, before I give the floor to you, Alex, so there's some, when we talk about the future events, there's some, mysteries involved, but then we will talk that later on, before we dive into more on the anomalies, actually.
Yeah, so I would like to really set this into a context here, because there tends to be a misunderstanding when I speak to professionals, especially in the context of anomaly detection. I always hear the term, like, if we compare the traditional monitoring, the traditional way of working with events, if we compare that to anomaly detection, and I myself, I was guilty of this in the past, because I used to think that, hey, normal monitoring, it also warns when something is not normal. So what is then really the difference between this more traditional monitoring ways of working and when we work with outlier detection and anomaly detection? And this is one of the keys, I think, to understand. And I'm going to try to put it here in a context that traditional monitoring, the thing there is that, yes, we can warn when something is not normal, but the difference is that there are people who set those thresholds. There are people who define when something is not normal and when something is normal. So, for example, if the CPU is more than 95% for more than 2 minutes, a person says that, okay, this is not normal, so we are going to create a rule for it, or a threshold in our monitoring system. But fundamentally, it's still people who are setting these thresholds, and there is like an endless tweaking of all of these different thresholds, and the people needs to learn the systems manually over time. How are the systems behaving? How are the servers behaving? And then you find yourself adapting these thresholds pretty much all the time. And 10 years ago, that was fine. But like I touched upon previously, when the sheer complexity has increased so much, then manually adjusting these thresholds all the time, it's simply not realistic anymore. And as an effect, you miss a lot of different events that are happening within your IT infrastructure. Anomalies, however, that's a bit different, because then we are looking at really two things. One is, like we spoke about before, the behaviors. So how are the applications, how are the metrics, and how is the data behaving over time? So that's when we use this time series database. And in a nutshell, we are then creating a baseline of, this is typically how the CPU is behaving for this particular server that belongs to this particular application, for example. And then when we see something which pops out, which isn't really normal, then we trigger an anomaly alert. But the key here is that it can only indicate whether something is abnormal or normal. It cannot really say if it's good or bad. We still need a person to indicate that. And I don't think that's going to change for a while. And then we have the predictions. So this is what you spoke about, Keith, when we really are predicting future events based on the historic data, and we can create these sort of predictive alerts. And I'm gonna try to explain this. So like Eli 5 explained to me like I'm 5. So what's the deal with predictions really? Well, if we're looking at this graph here, it could be like a graph on the CPU, or it could be of transactions or whatever it is. We see the blue line, and that's the things which is currently happening. And then we have the orange line, which is what do we predict will happen? And because we have time series data, because we have all of this data from the past, we can make fairly accurate predictions, or hopefully at least, of, how will the coming 5 minutes look? How will the coming 10 or 30 minutes look? Because we have a lot of history. So we know that last time this sort of event happened, last time whatever happened, then the IT infrastructure behaved in a certain way. So here I'm going to predict that behavior again. So essentially, we are detecting anomalies in the future which have not yet happened potentially. So I just wanted to kind of debunk these concepts and get it out in the clear there. So what is the difference between traditional monitoring and anomaly detection, and why is it so important? So this is truly what it means to be working according to predictive models. But you have more to say about predictions, Akif. So
yes,
there is a mystery around it. Because it's not just that simple, correct?
There's a mystery around the predictions because I mean, like, you know, you hope to capture actually in your model all the relevant data, all the factors that are relevant to make good predictions, right? So you want to know everything actually on one hand, because, you know, like you said, you know, when you make the prediction, whether it's like gonna be, you know, the anomaly or not, and you showed in that nice plot. I mean, what if you have like an historical data where you haven't seen any anomaly? Like you have to learn your models, you know, what an anomaly or how anomalous behavior, you know, should look like. But you know, the world is complex, and there are lots of, you know, that's why there's some mystery involved in predictions, especially like, you know, future, you know, predicting the future. But first of all, like, why are predictions important? I mean, you don't want to be a reactive agent. You don't want to be reactive, but like more proactive, like anticipate the future. And you want to, you know, predict anomalies, and why, like, you want to handle it before, you know, it becomes a problem. And this is important to stress, and otherwise then you know, it doesn't make sense, you know, all the tools and, you know, nice tools you have, and then you want to know which anomaly will really cause the problem, because I mean, when we talk about like outliers and anomaly, like, you can have an outlier because, you know, data is not like constant. It has like, it's varying, like get lots of different kind of data, you know, and then you try to fit them, you know, a model like, you know, nice machine learning, a statistical model, mostly like averaging the value. But I mean, there will be, you know, data points that should not be, you know, be in there when you construct your model. So when you create your model, there will be anomalous behavior or anomalous data in there, and you want to detect that and learn about it, and then so you can prevent it in the future.
So what you're saying is that the success of these statistical models depend on you capturing when things go wrong, when things are not as we expect them to be. And if you do that over time, you kind of learn that behavior of this is how it looks when it goes wrong. This is how it looks when it's normal. And but the success is really depending on when a crash happens, then you need to capture that data.
Exactly. Exactly, and we will talk about, you know, that more. But this is more in an ideal, you know, situation. So when you have ideal statistical model, it will do that. It will look at, you know, your data. It will say, you know, it's going to behave like this. You will have no problems at all, and you can, you know, run your IT operations very smoothly without any headache issues.
So what happens then, Akif? Because I think that's the next slide. What happens then when we have problems that never have occurred before, that are completely new to the statistical models and everything?
Well, then we get, you know, a black swan event, we call it. You know, it was coined by Nassim Taleb. And then actually, this is also the definition of mystery. So if you haven't, you know, captured the factors or like the data, you know, for such an, you know, event, I mean, that's why we called it like the mystery of predictions, not a puzzle of predictions. Like if it was a puzzle, we know there's a solution answer there. We just have to go and you know, look for it and find it. But you know, when we talk about the future, there are like factors and data that are like not known. I mean, there are known unknowns and there are unknown unknowns, and especially the unknown unknowns, like great guy once said it. The biggest catastrophic events come from there. And I also want to say, for example, when you create like statistical models and machine learning models, it has a certain accuracy. Probably 95% of the time they will be, right, and or even more. Like we can create really high accurate models, but still, you have to capture, that data, that factors that could cause, that anomaly, and then, take action. That's the second part, take action when you get the anomaly alert for, hey, there's going to be a problem. But coming back to that mystery part, so like the moral of this story with the medieval knight, I wanted to show actually, like, so, you have nice armor, you are prepared, but there's, small like opening to see, and then, you get a good bowman who, hits like directly you in the, in that small opening. That's so my question always is like, the moral of the story is, what is the probability that the arrow goes through that opening? I mean, 1%, maybe 2%, 5%, or maybe 0.1%. Then I always, state the Murphy's law that if anything can go wrong, will go wrong. Very pessimistic view, especially if it's systems created by humans. I mean, we also create solutions for it. So
yeah. So Keith, a question here, because I'm sure that some of the audience is thinking the same what I am thinking. Okay, it's, if we look at how problems occur in the IT infrastructure, if we look at how issues occur in applications or in our business services or whatever it is, if we have these issues and we capture them over long enough time, then we can, in a fairly accurate way, predict that, we have seen this pattern before, and now we start seeing the same things repeating again. So, like you mentioned, with 95% accuracy, yes, this is going to happen within the next 10 or 15 minutes, for example, and that's great. But often just like you said, the unknowns are the things which creates the biggest problems in IT infrastructure, that creates the biggest problems when we speak about running a business. It's the thing that that have never happened before, and that is very difficult to anticipate. So in your point of view, what would the future solution to this be? And are we there today? Can we cover those black swan events?
Well, it's a, let me come back to the definition of black swan event. It's the rare high impact, like, prospectively, in perspective, it's not predictable. Like, that's what I was trying to actually say. There will always, once in a while, a problem, an issue, that will have a high impact, but you could have, said, okay, this could happen. Like, let's say your servers could all of them at once, shut down. Yeah. It could, but then the chance is like 0.001. And maybe like, I don't know if it's a good example. Like, so we had that with, a couple of weeks or months ago with Facebook and WhatsApp. And right. I asked myself, how could this happen? Like, I couldn't, my WhatsApp and Facebook and, it didn't work. So, but it can happen. And that's not like happening often, or hopefully not happening that much, many times, which is difficult to capture. And the moral of the story is you should have a strategy, rules and procedures in your decision making in place. If in such case it happens, we can trust the ML and AI algorithms, like, to a certain extent, but still, like, you should have like a strategy in place in case of such an event happens. What do you have to do? Like, how should you, react? And then, with predictions, mystery, like, that's why it's mystery of predictions and not puzzle of, not a puzzle. And then the mystery, you have to, deal with it,
So what you're saying is there needs to be a process around it, that if we can anticipate, we can forecast, we can learn, the best behaviors of our systems, and to maybe a 95%, to maybe a 99% accuracy if we're really good. But it is that 1% which we will probably never be able to capture, that you also need some fallback methods for.
Exactly.
But I think the general, the consensus here is that predictions are really, really good, because then we are working based on historic things. We are working based on facts, on data, but they are at the same time not a silver bullet in all the cases. And I think those are fair expectations to set when we speak about AIOps and predictions, that not everything can be predicted for the reasons you has mentioned.
Exactly. And another thing, just to finish it, it's so business applications, the data from it, it's not like from the stock market, which is much more complex, lots of other factors. I mean, it has to behave in a normal way most of the time. So
it's a good point, actually. It's a good point. Most of the time data is behaving normally. With that being said, we only have 10 minutes left, and we have now discussed the theoretical concepts quite a lot. So we have been speaking about the pyramid of intelligence. What is the difference between machine learning and AI? What is time series and how do we capture it? Then how do we apply statistical models to it? And how do we create these baselines? And how can we try to forecast the future? So this all sounds good on paper, but a lot of questions, a lot of people, they often tend to ask the question, okay, that sounds good, but how can we get there? So that's what I wanted to stress here, is that when we speak about AIOps, especially ServiceNow ITOM and machine learning, it's of critical importance to have some tangible use cases. So this is something that we have worked with other organizations about, but as a first step. So again, this is just to give the guys and girls on the call an understanding of how could we do this ourselves, how could we start this journey in a very simple way. So first of all, the sources. Where do we get our metrics from that we will store in a time series database? Like you mentioned, Akif, we can use the agent client collector of ServiceNow, which kind of scraps the metrics and the matrix. And then we also have things like traditional application performance management tools that we can tap into metrics from. But then it's important, because when we start with this, I mean, there could be potentially hundreds of different metrics that we could measure and create statistical models for, but that's not really valuable. But rather, we should select a few critical metrics that we think are important, and maybe also for critical business applications. So minimize the scope a little bit and focus on really learning the behavior for a few metrics, maybe 10, 20, 30, rather than hundreds of them. And then do that for a set of very important applications, because then we get realistic, we learn this intimate behavior like you explained before, Akif. But then when we speak about use cases, so how can we pitch this? How can we refer to these things to management, or if we want to get like a buy-in from a VP or whatever it might be, we need to have tangible use cases. So just knowing the statistical models of our metrics, that's cool and all, but what are we going to do with it? So that is where we come to that ACT part in the pyramid. So I would say 4 very common use cases is, first of all, moving away from static thresholds. Using AIOps and using these sort of machine learning is a great way not to having to rely on static thresholds, because that brings me to the next point. We become aware of the behaviors of our applications. And when we are aware of those behaviors, we can start analyzing anomalies. And more importantly, we can start creating anomaly alerts, and we can act on these anomaly alerts. Sometimes it's fine. like nothing bad has happened. But other times, these anomaly alerts can be super good, important, critical business data to be aware of, that like, hey, we have anomalies in our system. We need someone to look into it before a user calls or before a monitoring tool warns about the CPU. And last but not least, to connect these anomaly alerts to the normal ITSM processes. So creating incidents out of them, maybe working with change management, etc. It's also very realistic things. So of course, we have only scratched the surface here now a little bit, but I wanted to end the note here with that it's not just a theoretical world what we're speaking about here, but this is available commercially off-the-shelf, realistic things to get started with. Even if it's in a small scale proof of concepts, it can be done. And I think that is super cool. So let's see, we've received some questions. I see you're also typing an answer there, Keith.
Yeah.
But then I'm gonna read out some questions loud here. So the first question is actually from Steinar, and he is asking, how far are we going to go in predict what might happen, and what is the cost of predicting? So I'm gonna quickly try to answer the first part of that question. How far do the predictions stretch? I think that depends on the model, if I'm not mistaken, Akif, and we can also influence this in ServiceNow, but most of the times it's like 30 minutes, and the further you go, the more inaccurate the prediction becomes, correct?
Yes, exactly, and depending on your data too. So if you have, for example, 2 weeks of data, I mean, then you can look at certain, set up a certain like window to how much you further can look into. Like,
right.
Let's say if it's 2 weeks, then maybe like 1 to 2 weeks into kind of the future, depending on the model and the data actually. And that's one of the factors you have to actually consider in your strategy, especially when you have when you want to install like predictive intelligence and do predictions.
Yeah, exactly.
That's one of the critical factors. So
basically, the more data you have, the further you can predict in the future, to like summarize it. And then there was also a question about the cost element. So what is the cost of predicting this? I don't have the exact, like if you're asking about the license cost, etc. I don't know that, but generally speaking, the cost of the predictions are fairly low. Like, again, you got to put this in a context, but let's say implementing this in a small proof of concept, it's a fairly quick project. It doesn't take too much time in my experience. So the cost of the predictions, the cost of storing all of this data is relatively low compared to only like 5-10 years ago. So that's what makes it a rather interesting part. There is also another question, which is how the variables of a time series are identified and how can they be corroborated?
So that's a very good question too. I mean, like when you get CPU data and all the data, so you can do it in 2 ways. You can beforehand theoretically set up like the variables, factors. You say this influence this, the data, how the data is generated. You can do it in a non-parametric way. Let the data decide actually these variables of factors or parameters in the statistical model. So yeah, there are 2 approaches in identifying these variables.
Excellent, thanks, Akif. And then there's a final question from Ika, which is if there's any implementations with Dynatrace so far. So even though we're speaking about ServiceNow ITOM here today, it's very common that we hook into data from Dynatrace, because Dynatrace is monitoring application and performance data. So that's a very common source actually. So with that being said, I saw we have one other question from Katarzyna. you have given a proper reply there. I don't have time to read it out loud.
Yeah.
But I'd like to thank the audience so much for listening to us here today. Indeed, it's a rather technical masterclass, but that's the future. It is a future of data and technologies. So I hope that we did a good job in trying to explain the high-level concepts. But if you on the call are interested in knowing more about these sort of topics, you, Akif, have written a very extensive report that we're going to publish tomorrow, more about predictions. So everyone on the call here, you will receive a link to Akif's report, but more importantly, you can always reach out to us. So it's just ping@einar.partners if you have more questions around this. Even if it's just like a technicality you want to discuss, it doesn't need to be a project. And of course, stay in the loop. So follow us on LinkedIn, follow us on our YouTube channel, and we will make sure to post more and more content in this area. And I'm certain that we will see your face again, Akif. So thanks a lot for joining me here today.
Yeah, so thanks. Thank you, Alex. Thank you. And
excellent.
Really great insights into to this from the business perspective.
Perfect. Then thank you, everyone, and have a nice day. And we'll be in touch.